We've all looked at mirrors before and seen reflections of ourselves, but we've also looked at some things that gave us reflections, but they weren't really clean reflections. You know, it might have distorted our face, or maybe we could sort of see colors in our face but not really see ourselves very well, and that's probably a diffuse reflection. So we're going to learn about the difference between regular and diffuse reflection in this video. We'll define the law of reflection, and we'll also look at how absorption, the different colors and how they absorb different amounts of radiant energy. We'll look at how those two things, reflection and absorption, can work together to harvest thermal energy and put it to good use. Mirrors are devices that consist of a really smooth surface, such as glass or something like that, and then there's a layer of silver on it that provides the reflection. And so to get a mirror, you have to have a really smooth surface, and you have to have something silver to reflect it, something shiny. And so it could be silver, it could be gold, it could be a variety of different metals that could provide the shininess, but the most important part of making a mirror is that it has to be smooth. If it's not smooth, you won't get a really good reflection. Mirrors, good ones, will reflect 100% of the light that hits them. And so when you look at a mirror, you see yourself because all the light that's hitting the mirror that was coming off of your body ends up getting reflected off the mirror, so you can see a perfect clean image of yourself. If you look at foil, it doesn't look the same. That's not a perfect reflection. Not all of the light is getting reflected back to you. And so mirrors are really smooth surfaces that reflect 100% of light, and images are the things that mirrors will produce. And that brings me to the difference between regular reflection and diffuse reflection. If the surface is really smooth, such as in this boat right here, with the water being super duper smooth and calm, you will get a regular reflection, which is going to produce an image that is clean and has no ripples in it. It's almost exactly what you're seeing. It might be reversed, it's backwards, but it's definitely going to be an image that's clean. A diffuse reflection, on the other hand, is when the surface is not smooth. A diffuse reflection occurs when the reflective surface is not smooth, and it produces a distorted image. So we see the boat here, but then the reflection is diffuse. The light is kind of bouncing all over the place as it's coming towards your eyes, and you don't get a perfect image. And to give you a diagram of that, a regular reflection, the light rays hit a smooth surface and they bounce off, creating this perfect image. But a diffuse reflection, since the surface is bumpy, the rays come in and then they bounce in different directions, which ends up distorting the image for you. A good example of this is if you look at foil versus a mirror. When you look at foil, foil is very shiny, especially on one side. The one side of foil that's really shiny is quite reflective. You can reflect quite a bit of light from it, but it's not nearly as good as a mirror. A mirror is going to reflect 100% of the light that hits it. Foil, on the other hand, if you kind of zoom in on it, you can see all these different little ridges and bumps in it. And those ridges and bumps cause the light to be reflected in different areas. So if you ever want to use foil as a reflector, it's not a bad idea. It's very cheap, but you need to make sure it's really smooth. The smoother you can get it, the better of a reflector it's going to be. And if you can afford it, a mirror is going to be the best option in terms of reflecting all the light. Some lakes, if they're really calm, will end up getting a perfect reflection, and they're just beautiful. They're practically mirrors. It's a really smooth surface. The light just hits it, bounces off, and you can see a perfect reflection. So why does light behave this way? How do we predict this? Well, it's all based on the law of reflection. The law of reflection is just something that always seems to be true. It's just always this way. When light hits a mirror, it's always going to bounce off at the same angle that it came in at. And so when you look at this incident ray right here, it bounces off at the same exact angle. These two angles, if you were to measure them, are going to be equal. And we put names on things in this too, so like the ray coming in is called the incident ray, and then as soon as it hits the mirror, it magically turns into the reflected ray. We just put labels on it like that. And then the normal always is perpendicular to the surface. It's always going to be perpendicular, kind of a 90-degree angle to wherever the surface is. In this case, it's a mirror. And so the incident ray, this angle, the angle of incidence, we call that the angle of incidence, is always equal to the angle of reflection. So by definition, the law of reflection says that the angle of incidence is always equal to the angle of reflection. The angle of incidence is this guy right here, the green one, and the angle of reflection is this purple one right here. So add something to your notes, just kind of with a picture or diagram. I think that'll probably be enough for you. So why is this important, and how can we put this knowledge to good use? Well, if we understand how light operates and how light reflects off of mirrors, and we understand that black is the best color for absorption, if we want to absorb all of that light, well, we can harness it and we can harvest it and we can make power out of it to power our homes and our cell phones and all kinds of things. We can use it to heat our houses. We can use it for so many. We can use it for cooking. So just to give you a couple examples, in California they made a new power plant called Ivanpah. You should Google it. It's Ivanpah. Ivanpah. It's a really, really cool power plant, but they ended up taking a gazillion mirrors, and there are actually 3 of these fields at this power facility. But 3 of these gigantic circles of mirrors and towers. And so all these mirrors reflect light to this tower. And notice that the tower at the tip of it is black. And so all the light that gets reflected, 100% of the light gets reflected using the law of reflection, gets reflected to this point in the tower. And then the black absorbs all of that thermal energy. And it's a ton. I mean, it's literally so much that they're having issues with birds flying through and catching on fire. I mean, it's that much energy. And so anyway, there's a lot of water that gets pumped through there. And as the water passes through, it's so hot that the water boils and turns into steam, and then they can take the pressure from that steam to spin a turbine, which runs a generator and generates lots of electricity for the people of California. So really, really, really cool. You can also take this down to a much smaller scale in a solar cooker. A solar cooker does the same exact things. You adjust your panels to make sure they're all reflecting sort of to the middle where your pot is, and then the pot is black. And the pot absorbs all the thermal energy coming from the reflective panels and ends up cooking your food. Thanks for watching, everyone. In this video you learned what a mirror is and how it produces images. Mirrors cleanly reflect 100% of the light that hits them. I guess that's if they're clean. On the other hand, other materials such as foil or maybe some choppy lake water might produce a diffuse reflection, which still reflects a lot of light, but not all in the same direction. This produces a choppy image that is somewhat distorted looking. After that, we learned about the law of reflection and how light always behaves when it hits a mirror. Forever you shall know that the angle of incidence is always equal to the angle of reflection. And all this is useful because if light can be controlled, it can be harvested and used to fulfill human needs such as energy and cooking. Take care.